What's up, techs? Today we're going to be talking about the F6E8 code on KitchenAid microwaves, the microwave oven combos, or just the microwave itself. We're going to go over some common symptoms, common issues, some test points, and basic electrical understanding when it comes to it. And if you hear noise in the background like that, that is the dog just enjoying his toy and scratching himself. Anyways, with that being said, yeah? Okay, thanks for waiting until I start recording to do that. Alright, so F6E8 code is lost communications with the microwave oven appliance manager. And basically, when you have the setup kind of like this, you've got the oven down below, microwave up top, user interface here. When you're first approaching these, they can be a little daunting if you're not sure what you're working with. So the goal of these trainings, and now the cats are making a whole bunch of noise. Hey, cool it. Yeah. And if you don't really know what you're dealing with here, it can be kind of confusing. And part of the point of these trainings is to kind of familiarize yourself with these, so that way you know what you're walking into, rather than just replacing parts based on what the tech sheet and service manual might say. So with that being said, let's dive in. On this style, this is going to be the wiring diagram you're going to be looking at. Before I really talk about the text here, you got the Copernicus appliance manager, you've got the microwave appliance manager, and you've got the user interface. So one thing to look at with this, when you get the UI lost communication with the oven board, what it's talking about is this board right here. You got your communication line comes up there, and we got that there. We're going to dive into that here in a minute. But pretty much with this style configuration, the oven appliance manager is what supplies power to the user interface. So some of them you're going to have like an SMPS right here which supplies it, but on this configuration in particular, we've got our Copernicus appliance manager, 120 volts comes in here, then it supplies DC voltage to the user interface for it to wake up, light up, and do its thing. Now with that being said, when we have power supplied from this to here, what it's looking at between here and there is a communication signal. So the other thing to note with this style, or with the KitchenAid kind of like this, is the user interface contains the logic for both the oven and the microwave. And the thing too also to remember is that these UIs are used on a variety of products in the Whirlpool brand. So with that being said, when you order a new user interface, and I've seen this a lot, put a new UI and then it gives you different issues. You know, first thought would be, got the wrong one, but within here, when you go into diagnostics, there's actually a menu where you can select, I think it's like system information. It'll show you the model number. And from there, you can select a different model number. So that's just one thing to keep in mind when you go to install a new UI. Make sure you have the right model number in there. So I'm not really going to dive too much more into that. But basically, when we get the F6E8 code, that's the microwave appliance manager not communicating with the user interface. And remember what I was just saying, the appliance manager for the oven is what supplies power to that. So we could not have any power to this board, but the UI is still going to light up. We're just not getting any communication from this control board. So when we look at what the tech manual says on this for the F6E8 code, it pretty much just says check the wires between the two. If it's good, replace the appliance manager. And then if the issue persists, replace the user interface. It doesn't really detail any useful checks. So when we come down to communication between the two, it's going to be DC voltage. And it's going to kind of fluctuate around depending on that. There's certain signals it sends, and we're not going to dive into that too much, but there should be some DC voltage on this P26 connector. Yeah, thanks, bud. Thanks. So with that being said, one metric you can check for, of course, is if it's sending DC voltage. If it's not, then you might have a bad appliance manager. That's not always going to be the case, and the main reason I'm making this training is because I've seen a lot of techs out there replace the appliance manager based on these instructions, and then the issue's persisting, and then we end up finding something else. So again, when it comes down to communication, you got this P26 line, that's what communicates with the UI. It's going to be a small DC voltage. If you're getting that, then the appliance manager should be working like it should. With that being said, if you're not getting any DC voltage, or if you're still getting that P26, let's kind of dive into what's going on with that and the most common issues that I see. So for the microwave appliance manager board to talk to the user interface, it needs power. And when we're talking about, let me see, we're talking about this board right here, we want to see how it gets its power. And hold on. Hey, Herbert. He does not look like he wants to play. Herbert. Sorry, Oscar. Oh, boy. And anyways, back to it. So for the appliance manager board to talk to the user interface, it needs its power. And again, the UI is powered by the oven board, but the oven board does not power the microwave appliance manager. And when we go back up to this diagram, you can see there's nothing connecting the two of these. So the oven appliance manager is getting its line 1 in neutral right there on the J8. It's got the DC communication between that and there, but when we're looking at the appliance manager for the microwave, it's getting its voltage through the line filter. So let's go back down here. So our line filter supplies 120 volts to the microwave appliance manager board, and that supplies voltage to, the microwave light, the magnetron fan, the turntable, and whatnot. But the chief thing that we want to look at right here is how it's getting its voltage, and it's going to be on this P1 connector. You're going to notice you got 3 wires. You got a blue wire, got another blue wire right here, and then you've got a brown wire. So when we're looking at the diagram, we're breaking the wiring diagram down to what is relevant to us. We want to know how the board is getting its voltage. So when we color it in, it makes it a lot more simple, but we got 120 volts comes down through here. First stop is this line fuse, and then it branches off and it comes straight down to the board. Plain and simple. Now we've also got this primary interlock switch, so when the door is open, we'll be getting 120 volts right down there. And that's just going to let the appliance manager board know, hey, door is open, let's go ahead and kick on the light. When it's closed, this line actually comes down, goes to the 4903 relay over here, which supplies voltage to the inverter on this for the magnetron. But that's not really what we're worried about. Right now we're worried about this coming here. So one of the first checks that you can make when you're out on a call and you're getting the F6E8 code, does the microwave light work? When you open the door, does that microwave light come on? If it does, then we can safely assume we've got 120 volts to the board and the board's working. Now, of course, with that route, it's just an easy, quick check to make where to focus your efforts. Not saying the light's not bad. It could be a bad light if you open the door and the microwave light doesn't come on. But for me, when I come out on one of these service calls and the light doesn't work, my first thought is going to be this fuse. So again, it could be the light not working. It could be the microwave appliance manager's not getting power. 9 times out of 10 on these calls, end up finding this fuse is bad. And this is why I wanted to kind of go through this training with you. It's just a process of making your checks. But I think part of the biggest difficulty it is with being an appliance technician in today's economy or in the landscape of appliances today is when you're dealing with, let me go back up, when you're dealing with appliances that have 1, 2, 3 control boards or 3 different boards, it's kind of like, well, what's going on? There's a lot of stuff going on here. I mean, until I learned about this, it's like I wouldn't have been able to tell you that the appliance manager powered the UI. And there's just communication between these two. I would have looked at this and just been completely lost. Microwave's not working. It's probably the microwave board or this, but that's the point of training, is so you can constantly learn new things. So with that being said, see if I can find my spot. There it is. So let's say you access the microwave appliance manager. That's going to be this P1 connector we're looking for. And you check between these two right there. This is where neutral comes up to the board. You can see it's just traced right through there. Through that cavity thermostat comes up. And then we have 120 volts. So let's say you're checking P1's pins number 3 and 4, and you're getting 0 volts. Well, why are we getting 0 volts? Where's our voltage missing? Again, you got this 20 amp line fuse. That's a solid contender. Could be the line filter's not working. It could be we're missing voltage there. But again, when you look at the appliance as a whole, let me go back up to this other diagram. Here we go. It's kind of tough to see, kind of cropped it off. L1 comes in, branches off, goes to there, and then it comes down, branches off. So L1 supplies voltage to both the appliance manager and the Copernicus appliance manager. So if our user interface is working, there's a good chance we've got 120 volts at least to that line filter. Now again, I mean, you can't really make assumptions in this field because you'll see anything and everything. With that being said, during your initial diagnostics, you kind of use the power of, or the process of elimination to figure out where to focus your efforts. So let's just say we're testing right here, and across those two we're getting 0 volts. Well, I would come up next to this 20 amp line fuse, I would check my AC voltage across that. Remember, when it comes down to voltage potential, voltage drops, concepts like that, that's what we really impress upon you with the Appliance Tech Academy training, because it's a valuable skill set to know. So if you're checking, when you're checking, let's just backtrack here. If you're checking here to there and you get 120 volts, you're reading the voltage potential difference between line, which is 120, and neutral, which is 0 volts. Now, if you were to put one lead right here, let's say this is the circuit as it is, our line fuse is working. If you were to put one lead right here on this red wire, and you were to put another lead right there, even though this is a 120 volt circuit, 120 volts is energized there, you would read 0 volts. And that is because there's no potential difference between 120 volts right here and 120 volts right there. But when you check line to neutral, you get 120 volts. Again, voltage potential. You have a voltage potential difference between neutral, which is 0 volts, and line, which is 120 volts. And I'm really driving this point home because this is a solid diagnostic tool that's going to help you focus your efforts. And we're going to dive into that here a little bit more. So let's say we check line to neutral, we're getting 0 volts. I would next be checking that line fuse. And if you check AC voltage across that line fuse, and you get 120 volts, that means neutral is pushing back through. It's coming all the way back up through here. So if this fuse is open, this red line right here would be neutral. It would be 0 volts, and this would be 120 volts. So if you checked across this and you're getting 120 volts, that fuse is bad. Now, of course, you can go find the breaker, unplug or hit the breaker, come all the way back, pull that fuse out or pull a wire off of it and then check continuity. But when it comes down to diagnostics and being an appliance technician, you want to be in and out as quick as you can. So for me at least, if I can check for live voltage and I understand what I'm looking at, that's going to save a lot of time. Because sometimes the breaker box, you'll be up in the kitchen, the breaker box will be down in the basement across the other side. You have to go past some stuff. You know, that's precious time that you could be spending actually fixing the appliance. So anyways, with that being said, on this unit, at this P1, pin 3 and 4, 120 volts should always be present there. It should always be present. That's the power supply to the board. So it knows what to do when, you know, when it sees 120 volts here or 0 volts there, it knows what to do. So let's take a look at one other thing, and this is kind of circling back around to the whole voltage drop and voltage potential concepts, because I've seen this before. You come up here and let's say you check, you know, you don't have the luxury. Let's do this. Let's say you're checking here and you don't have the luxury of a colored in diagram to show you where voltage is. You're checking from there to there, you see 0 volts. You think to yourself, okay, we're not getting any voltage. It's probably this fuse. You come check the fuse and guess what? It's good. It passes. Well, then what? If you got 120 volts there, or if you have 0 volts when you're checking those two, and this is good, then guess what? And this is where voltage potential really comes in handy, understanding this. Let's say we have a bad cavity thermostat. I've seen a couple of these be the case before. We checked across from there to there, we're getting 0 volts. But when we checked each of those lines to ground any exposed metal surface, we get 120 volts. Now we know we want 120 volts on this brown wire coming in. We should have 120 volts there. But on this line, this is how the control board gets its neutral. Again, circling through here, neutral comes up through there. So when you have line voltage on one side of a load and neutral on the other, that load should work. When you are missing either line or neutral, that load becomes a conductor. It just allows voltage to pass right through it, so it kind of backfeeds through. So in this scenario, we have a bad cavity thermostat. It's open. It's failed. Line voltage would then pass through the entire control board and come right back out on that neutral line, and it would sit right there. I've seen this before a couple of times, which is why I'm including it in this training. If you check the neutral wire to ground right here at this connector, and you get 120 volts, that means you're missing neutral. And this is why it's such an important concept, why I spend so much time driving this concept home in pretty much every training that I do. Because I don't need to spend time looking all over for where the cavity thermostat is. Most of the time it's up by the line filter on this unit. But I don't need to spend a whole bunch of time like tracing out wires, looking at things, trying to figure this or that out. When in reality, I can just find this one simple test point and I can figure out where to focus my efforts. If I'm getting 0 volts on this line to ground, then guess what? I'm looking at that line fuse. If I'm getting 120 volts to ground on this line, then I'm looking at the cavity thermostat. Those are the two solid contenders there. And of course, if I go to that, and I'm having 120 volts across those two, then guess what? Our cavity thermostat opened. Or vice versa, if I have this kind of voltage here, I go up here and I see 120 from there to there, then I know my issue is somewhere between the board and here. Again, that boils it down to a process of elimination, and this is why wire diagrams are so important, and understanding them, and then also understanding voltage. So with this training, is kind of brief, basic, cursory. Tech sheets are often pretty cursory, and they don't really provide relevant metrics sometimes. As you could see before, all it really said was check the wiring between the two. If it's good, replace the board. Now, as an appliance technician, that's not the type of data that I want to see. Those aren't the testable metrics that I want to see. I want to be able to check my stuff, check voltages. I want to be able to check continuity, resistance, what have you, to determine where the issue is, not just check wire connections. If they're good, replace this board. I've seen so many techs do that, and that's why we're making these trainings, to go over common issues that you're going to see in the field. But it's also to work to instill the basic diagnostic process with you. Because if we're just replacing parts left and right and not actually making checks, you're not doing your job right. You're going to look bad in front of the customer. You're going to look bad for your company if you replace a board and it's doing the same thing. Customers don't like that. They don't like to agree to a $300 repair just for you to say, oh, it turns out it's an $8 fuse. So really, as a technician, it's up to you to know what checks to make. And if you're watching these training videos, then I'd like to think that you're on the right path, because you're looking to improve yourself to be a better technician. There are a lot of technicians out there who feel like they know what they need to know, and they're not doing anything to work to improve that. And that's when I feel like technicians start going downhill, is when they think they know enough and then they stop their training. With appliance repair, it's an ongoing process. It's an ongoing training. So most of the time, it's just a matter of tracing voltages. As we could see back here, if we have 120 volts on each of these lines to ground, then we know we're missing neutral. So we're tracing our voltage, and we can find out that the cavity thermostat is bad. I can't say that I've ever really seen a bad line filter, but of course I'm not going to rule that out. If I trace voltage back and I have 120 here, and then I have 120 to ground here, but on the other side of the line filter I have 0 to ground, then I'll know the line filter's bad. It's not really, for me, a process of, oh, well, typically it's going to be this or that. That's where I see a lot of other techs go bad too. Oh, well, in my experience it was this, so I didn't make any checks and I just replaced it, and now the issue's still going on. You kind of catch my drift? When it comes down to fixing appliances, tracing voltage, especially when it's electrical. Those are often the easiest ones to figure out because it's just figuring out where the voltage is and where it isn't. Looking at your wiring diagram and reducing the problem. If we're looking for voltage here and we're not seeing it, then where are we missing it? So if you're getting all the proper voltages and are still getting that error code, then you're likely looking at a bad appliance manager board. So if we have 120 volts here, and we have maybe no DC voltage on that connector up there going to that, then yeah, I would say you probably have a bad appliance manager board. But even on that note, you'd still want to check all the wiring and all the loads to see if there's anything that caused the board failure to begin with. So that pretty much sums up this training for today. Hope you learned some stuff from it. I tried to keep it short, but now I'm seeing it's about 21 minutes long. But of course, and we really try to drive the point home in the best of our ability. So if you want to learn more about appliance repair, head over to appliancetechacademy.org, sign up for the program, and get learning.